So I want to cover redirection. So how do you make something redirect to somewhere else from Nginx? Not too hard, but a useful command. We're going to talk about Gzip, what it is, how compression works. And then we're going to add a subdomain to your application, just in case you need one. It's always helpful to do that, and it's a little bit tricky. Or it's not too tricky, but it's not as intuitive as you'd think. So the first one, if you want to modify your virtual configuration, your virtual server, and say, oh, when I go to gemstack.lol/help, it actually just redirects me to the Mozilla developer documentation. You can do that. You don't have to do this right now. This is just an example of how to do a redirection in Nginx. Let's talk a bit about Gzip. Anybody know what Gzip is? Have you heard of it? Well, most things not most things, HTML pages, etc., by default are gzipped. A lot of things are gzipped. Gzip is just a compression algorithm that is run on Nginx that compresses things. The browser, it's one of the few things the browser actually knows how to do. So that way, we're not sending these massive files over the wire. We're actually sending compressed files over the wire. And the browser knows how to unpack them. Nginx knows how to pack them up. We can adjust our Gzip settings in /etc nginx conf. And you scroll down to Gzip, and you can set the level. Now, the temptation is always to set the compression level, which stays about 6 by default. You want to say, like, oh, I want to turn up to 9, which is as high as it goes. But remember, that means every single connection coming into your computer needs extra CPU power to do that compression. So it's got to take those files, and it's got to compress them. And it's got to decompress it the other way as well. So generally, 6 is considered the right balance between speed and performance. If you're like, hey, I'm not running a lot and I want as much performance as possible, turn it up to 9. But in general, in a production system, you're not going to do that. And feel free to play with it in /etc, so it's vi, etc, nginx, nginx conf. If you want to mess with Gzip, you don't need to, but it's nice to know it's there. But how does compression work? And this is my most simplified example I could think of. So a compression algorithm is just a way of rewriting a file, essentially, in a much shorter hand way. So a file is always going to break down into ones and zeros at the core. That's what we're doing right now, just moving ones and zeros around. So what if, instead of having this long chain of ones and zeros, we just describe it a little bit differently? So a compression algorithm will say, hey, you got this line of code or this file. How about we just describe it as it's 4 zeros, and then 3 ones, and then 1 0, then 1 ones, and then 5 zeros. And you do that over and over and over again. And it turns out you have this giant megabyte or gigabyte file, and you can compress it down to a few megabytes just by describing it differently. And that's how a compression algorithm works. And there's different ways of describing the files. Now, you're saying, that's awesome, Jem. What's the difference between compression and hashing? Because they seem a little bit different, or they seem very similar. Well, compression always has a fixed output, and it's going to be as small as possible. Versus hashing, we don't actually care about the size as much. So that's really kind of the difference. And one is designed to be unpacked. Like, you can't compress something without uncompressing it. Otherwise, what's the point? Versus hashing is not necessarily designed to be reversed the other way around. And this is just a random fun fact, because we're front-end engineers here. You can't gzip a picture. Why not? Or you can, but it won't do anything. Why not? That's right. Images are already compressed. That's why the old days, anybody who played around with bitmaps knows that like a bitmap is 5 megabytes, but a PNG of that same image can be 30 kilobytes. Because PNG, I'm trying to think of some other, what are some other image formats? JPEG.
Isn't that lossy?
JPEG can be lossy, yeah. And PNGs isn't necessarily. But those are just compression algorithms we're talking about. You remember MP3s? I know I'm dating myself. I can't believe people don't know what MP3s are, but
how do they not know what did everybody move over to FLAC or something?
Some people don't know what MP3. Like, why would you know anymore with Spotify and YouTube Music and all that?
I guess.
Yeah, MP3 is what? A compression of a WAV file. And they're all from the same group. JPEG is Joint Picture Expert Group. MP3 is Motion Picture, or that's MPEG, but same Motion Picture Expert Group again, but that we compress it down to MP3. But yeah, these are just compression algorithms, like really, really powerful things.